Hello, welcome to CSE 226 System Analysis and Design class. My name is Dr. Ifeyinwa Aja, the course lecturer. Before we begin, it is important to acknowledge that the slides used in this presentation is adapted from System Analysis and Design textbook by Dennis Wigzom and Roth. In this lesson, we'll be looking at process modeling. But let's begin by looking at the learning objective. Here, we'll be defining what process modeling is, describe the element of data flow diagram, discuss different levels of data flow diagram, explain the rules and styles guiding data flow diagram, describe process used to create data flow diagram, and at the end, we should be able to create our own data flow diagram. What are the key definitions in this session? One is process model. What is a process model? It's simply a formal way of representing how a business process operates. It illustrates the activities that are performed and how data moves between them. Basically, we have two types of process models. The logical process models that describe process without suggesting how they are conducted, and the physical process model that include process implementation information. So this is basically the difference between the two. Now, for you to create a process model, we use a diagramming technique called data flow diagram. This is a popular technique for creating a process model. What do data flow diagram tell us? If you look on the screen, you will see example of a process model, which shows a blueprint of functionalities being performed by a system that is modeled. Well, before we can interpret this or able to read this very well, we should be familiar with some of the elements of the data flow diagram, some symbols that are used here. And each of these symbols represents something. What are these elements? Basically, you can see 4 elements there, which are the process, the data flow, the data store, and external entity. It is also important for us to notice here that we have two types of symbols that can be used to denote this. We have the game and Simpson symbols, and we have the Marco and Jordan symbol. Now, it is important to mention here that you have to be consistent in using your symbol. It is either you go for the game and Simpson symbol or you go for the DeMarco and Jordan symbol. If you look at some textbooks, a particular one is being used. So in these two types of symbols, you can see how they use different symbols to represent each of these elements. But for the purpose of this presentation, we will focus on game and Simpson symbols. But if you see the Marco and Jordan symbol in a textbook, still know that they are talking about the same thing. Now, for a process, every process has a number, a name, and this name is usually a verb phrase, a description, at least one input data flow, and one output data flow. Then we have the data flow, which is represented by an arrow. Every data flow has a name, which is usually a noun, a description that explains the type of data or the nature of data that goes in, one or more connection to a process. Then the other one is a data store. A data store is just simply a database that houses data that is being captured, the entity that information is being captured about. As we go on, you will understand what I mean by that. So a data store has a number, a name, which is also a noun, a description, one or more input data flow, and one or more output data flow. Finally, we have external entity, which has a name, usually a noun, and a description. Now let us see it more. You can see an example, a symbol here on the screen, which is a process, and you can see a number there, and you can see a name such as prepare pickup manual. So it is an action. It defines an activity. That is an action. It defines an activity or function that is to be performed for a specific business reason. It can be a manual or computerized process. Now, it is important for us to know here that you can use DFD to create either a manual or a computerized system. In other words, you can also use it to represent either your a current system or a new system that is being proposed. So it is not just for a particular one. Now we have a logical process model. In the logical process model, you have to omit, that is, in creating a logical process model, you must omit any process that simply moves and routes data and leave the data unchanged. So you cannot use a process to represent, any action that does not perform anything. So you include logical processes that can perform a computation, make a decision, maybe to compute a grade, to sort a file, to organize it. So it must be doing something, or something that triggers another process. So that is what you represent as a process. Now, this is the data flow, which you can see here. As represented here, we have a data flow called new chemical requests. So a data flow is simply a single piece of data or logical collection of data that goes into a process or come out of a process. Data flow names describes the content of data flow, but not how it is implemented. It doesn't show you how it is implemented. It just describes the content of that data. It always starts and ends at a process. Then we have a data flow. A data flow can be described as a data in motion, an input of data to a process or output. We've said that can also be a creation, deletion, update of data in a file, that is a database. And it is usually depicted as a solid line with arrow. Note also that there is what we call a control flow, which is depicted by a dotted line. This can be used to show, trigger a process such as time to run a weekly payroll. What is data store? For data store, it's just representing a database. The store that stores different things, information is being captured about. We know that most information systems capture data for later use. So a data store is simply a collection of data that is stored in some way. If we see data flow as data in motion, think of data stores as data at rest. Just like I mentioned before, it is just that thing that information is collected about. Data flow that leaves the data store are data retriever. Then those that goes into can simply be updates on new data added. Then finally we have the external entity, which is are persons, organization, or system that are external to the system being modeled. It has interaction with the system. Now, how do we depict a business process using a data flow diagram? it is very complex to use one data flow diagram to represent an entire system being modeled. So it's usually a good practice to decompose them, break them into level for better understanding. And that gives rise to different hierarchies or decomposition that comes in when you are creating a data flow diagram. Let us look at these different levels. Basically, we have the context diagram, we have the level 0 diagram, we have the level 1 diagram, and the level 2 diagram. As we can see, the context diagram is a high-level model of the system. It is usually the first diagram in a DFD diagram, and it shows the system in a holistic view without giving you further details about the system. And how do you recognize a context diagram? It usually has a number 0. The process there is represented with a number 0. If you see a 0 on any process, it shows you that that is a context diagram, and the name usually bears the name of the system being modeled. It shows you the system being modeled, the entities that interact with them, and the data that flows in and out of them. Now, the next level is the level 0 diagram, which shows you the main processes that the system is meant to do. Now, when creating your DFD diagram, ensure that these main processes are those key things that key processes that target the key problem that the system is meant to solve. Like if you look at what we have on the screen, you can see process T, process U, and process V as the main processes that this system in question is to do. Now, on this level, you can also see the entities that perform a particular process, and a data store that is being referenced for a particular process. It must not necessarily be one data flow. So as many data store as possible that are referenced are represented in this level. If you can see now, there are 3 processes. You can have more than 3, you can have less than that. It depends on what the system you conceptualize and what you are creating. Then after level 0 diagram is level 1 diagram, which is a further decomposition of level 0 diagram. Now, if you look at your level 0 diagram and you notice that there is a process there that involves several activities, so you need to bring it down to a level 1 and expand it. So at this level, you can have different fragments of each of the processes in the level 0 diagram. But this is only necessary if there is a process in the level 0 that needs to be exposed further. Like you can see here, process 2, which is process U, is further decomposed in the level 1 diagram. That is why you have it as level 1 DFD for process 2. In the same manner, you can have level 1 DFD for process 1 or process 2, and so on and so forth, as the case may be. Now, in that level, you now depict the activities that are involved in performing process U, which is represented in the level 0 diagram. And as you can see, you will notice 2.1, 2.2, 2.3. This means that for you to perform process 2, you have to do these 3 main processes. You also see the data store that is involved in it. Now, from level 1.0 diagram, you can create the level 2 diagram. It's not compulsory that you must have level 2. You need level 2 if at level 1 you discover that there is a process there that needs further decomposition. So what this thing means is that you can have different fragments of different processes that you identified at level 0 diagram, and you can bring them to level 1 and further to level 2. This is a description of the different, they have the hierarchy, as I've explained. Another thing to mention here is the need to balance your DFD diagram. So you have to make sure that your diagram is well balanced by ensuring that information presented at one level of DFD is accurately represented in the next level DFD. Data flow on parent diagram are carried down to child diagram, and child diagram adds new processes and new data flow. So as you can see, different illustration of different levels of data flow diagram. Here is the context diagram showing you a system, the entity that entities that interact with the system without giving you further detail. Then you have the level 0 diagram, which shows all the major processes that comprises the overall system. It shows you the key processes, the data store that are connected, that are referenced, and the entities and data that flows in and out of them. Now you see the level 1 diagram, which is a further decomposition of a process in the level 0 diagram. Then finally you have the level 2 diagram. So it shows all processes that comprise a single process on a level 1. So like I said before, there mustn't be level 1, level 2, level 3. It is the system you are modeling that will determine where to stop. Then we have the diagramming numbering. We have already said that context diagram is always process 0. Then for level 1, level 0 process, level 0 diagram, you depict the main processes. It can be 1, 2, 3, or more, depending on what your system is solving. Then at level 1, you can decompose a process in a level 0 diagram by using a number. Like if you can see here, you have at this level 1, you have 1.1, 1.2, and 1.3, which shows that the process 1 in level 0 is further decomposed here. If you go down to level 2, you will discover 1.1.1, that 1.1.2, and so on and so forth, which means that the 1.1 process in the level 1 diagram is further decomposed here. There are also what we call alternate data flow, because there are some processes that may have conditions attached to them. For instance, now let us look at maybe to log in as a process. Let's just use that as a simple analogy. You see, what you look at a use case, what happens when one logs in? There are two use case scenarios. It's either that the person logs in successfully, or for one reason or the other, the login may not go, and that defines an alternate path. So what if that does not? If for instance a user enters a wrong username and password, there should be an error. It will trigger an error that will tell you what next to do. That is what we call an alternate path. So we show both data flow and use the process description to explain why there are alternates. And these alternative data flow are often accompanied with if statements. So this is a case entry of a process description. Like you have a data flow diagram, you can see where it is represented in a use case. At this point, let us have a reflection on what we have done so far. So you have your turn. I would like you to describe in your own words the contribution of data flow, data stores, and processes to a process model. You should also describe the relationship between DFDs and the ultimate new application being developed. Thank you.